When a cloud fell and 3I Atlas slipped behind the sun hook, 3:11 a.m. Eastern Time, October 20, 2025, Northern Virginia. In a windowless operations room at an AWS campus outside Ashburn, a senior incident response engineer named Maria Thompson watched her dashboard turn the wrong shade of red. DNS error rates in U.S. East 1, the company's busiest region, spiked from fractions of a percent to nearly total failure in under 60 seconds. Authentication calls piled up. DynamoDB latencies climbed from double digits to timeouts. On internal chat, someone typed, "Is this a drill?" and no one answered. 10 minutes later, millions of users across the United States discovered that refresh no longer helped, food delivery apps failed, hospital dashboards hung, and a dozen newsrooms lost access to their publishing backends just as the East Coast began its day. While engineers scrambled through dashboards in Virginia, a different kind of screen lit up in Baltimore. At the Space Telescope Science Institute, where NASA's James Webb Space Telescope is operated, staff scientist Michael Reyes opened an automated alert from the night's data run, 3I/Atlas, final preconjunction pass completed, SNR acceptable, unusual CO2, H2O ratio persists. In a single sentence, the alert tied together three threads: a newly discovered interstellar visitor, a spectral anomaly that had annoyed the team for weeks, and a clock running down toward solar conjunction, the period when the sun would hide the object from almost every instrument on or near Earth. 12 hours later, astrologers on TikTok, anonymous Reddit threads, and a handful of late-night cable hosts would mash these two events into a single narrative: the morning the internet faltered and the alien rock vanished behind the sun. By that evening a hashtag 2vanishings, would float alongside another, more aggressive one, #NeptuneRisk. Because buried in the scientific chatter was one more unsettling line from an internal memo, a note that the preliminary orbit of 3I/Atlas placed its inbound trajectory frighteningly close to Neptune's orbit earlier in the year, raising, at least in theory, the question no planetary scientist ever wants to see in writing: what happens if a superdense interstellar fragment meets an ice giant head-on? Lead. On October 20 to 21, 2025, two seemingly unrelated disappearances occurred on American screens. A major cloud region serving much of the U.S. went dark for hours, and 3I/Atlas, only the third known interstellar object to cross our solar system, slipped behind the sun into a period of observational blindness. Over the past month, a dense web of scientists, engineers, security officials, and online commentators has tried to decide whether these were just unlucky coincidences, early signs of a new class of cosmic risk, or something more human, an infrastructure that has grown too complex to fully trust. This first part traces how 3I/Atlas was found, how U.S. East 1 became a systemic weak point, and why a handful of orbital fits involving Neptune turned a niche scientific debate into fuel for an information war. Context and background: interstellar visitors are supposed to be rare, almost mythical events. Before 2017, the standard model in planetary science textbooks said that bodies ejected from other star systems probably drifted through the galaxy, but no one expected to see one soon. Then Pan-STARRS in Hawaii spotted 1I/Oumuamua in October 2017, a faint, fast-moving object with a light curve so strange that it drove half the exoplanet community into arguments about shapes, outgassing, and non-gravitational accelerations. 2 years later, 2I/Borisov, a more conventional-looking comet, confirmed the category. Interstellar interlopers were not a one-off. By the time 3I/Atlas appeared in mid-2025, American observatories were tuned for them. The Atlas survey, run out of Hawaii and partly supported by NASA grants, flagged a moving point of light in July with an unusual inbound speed and a trajectory that didn't match any cataloged object. Follow-up observations from Arizona and New Mexico refined the orbit. Within weeks, the International Astronomical Union quietly gave it the interstellar designation. 3I, informally, everyone called it 3I/Atlas. For the public, the name barely registered at first. For scientists, it was a third data point in a still tiny sample. 1I had been weird, 2I had looked familiar. The question now was which way the pattern would tilt. NASA moved quickly. Using existing observation time blocks and a bit of political pressure, the 3I/Atlas Science Working Group secured a series of JWST observations through late summer and early fall. Webb's infrared spectrographs are designed to dissect exoplanet atmospheres, brown dwarfs, and dusty galaxies. Pointed at 3I/Atlas, they could, in principle, tell whether this object was more like a comet, a rocky fragment, or something in between. At the same time, a loose network of US-based optical telescopes coordinated polarimetric measurements, studying how the object's light was polarized as it reflected sunlight. Polarimetry can hint at surface texture, particle size, and composition. Across all of these plans, though, sat a deadline: solar conjunction. Solar conjunction sounds exotic, but it is mostly geometry. From Earth's perspective, any object that passes close to the line of sight to the Sun becomes extremely hard to observe. Glare overwhelms it. Instruments are risked by pointing so close to the solar disk. For Mars missions, conjunction means weeks of interrupted communication. For 3I/Atlas, it meant a blind window of several weeks in late October and early November when both ground-based telescopes and JWST's field of regard would lose the object. Practically, the most promising new interstellar object in years was about to vanish behind a curtain of light just as its spectra started to look strange. While astronomers were fighting for every preconjunction photon, another set of engineers was managing a very different kind of system in the United States. AWS-US East 1 in Northern Virginia is not just a data center, but a cluster of facilities, fiber links, and control planes that underpin thousands of companies. Authentication services for consumer apps, hospital records, airline booking engines, education platforms, many of them route through this region directly or indirectly. To most Americans, the region is invisible. To people like Maria Thompson, it is the nervous system of the digital economy. Internal training materials describe US East 1 as a multi-availability zone region with redundant power, network, and control plane components, yet incident reports from past years read like quiet warnings: misconfigured capacity scaling leading to cascading failures, subtle DNS issues causing unexpected service degradation, and occasional stories of slow burns, small bugs that only triggered under very specific load conditions. Layered beneath both the Atlas survey and US East 1 are older pieces of infrastructure that do not trend, meme, or post. Submarine cables such as AAE-1 and CIOS routes that snake along the seafloor between continents, and Mediterranean loops bridging Europe with the eastern United States, still carry a large share of global traffic. The United States is woven into these systems by decades of telecom investment. When a segment is cut by a ship's anchor or damaged by a landslide, traffic reroutes automatically, often adding milliseconds of latency that only specialized tools notice. These tools, BGP monitors, latency probes, synthetic transactions, are the seismographs of the Internet. They share something with the sky surveys hunting for objects like 3I/Atlas. They are always watching, always logging, and mostly ignored until a graph bends the wrong way. Finally, there is the political background. The United States is a central player in space governance, both through NASA and through its role in the UN Committee on the Peaceful Uses of Outer Space. In recent years, under quietly updated, no-reply guidelines debated in think tanks and academic conferences, U.S. agencies have been urged to proceed cautiously when interpreting potential technosignature candidates, signals or features that might, in principle, indicate technology beyond Earth. Anomalies must be checked, cross-checked, and publicly documented before any declaration. At least, that is the policy on paper. In practice, as 3I/Atlas approached the inner solar system, the lines between scientific caution, national security, and public communication grew more blurred. Timeline: July 3, 2025 2:19 Hawaii Standard Time. Atlas survey in Hawaii flags a fast-moving object with unusually high inbound velocity. Preliminary orbit suggests an interstellar trajectory. July 5, 2025 2040 Mountain Daylight Time. follow-up images from the Lowell Observatory in Arizona confirm the object. Internal circular at NASA labels it Interstellar Candidate 3I. July 21, 2025, 14:10 Eastern Daylight Time. International Astronomical Union issues a brief internal bulletin designating 3I/Atlas as the third confirmed interstellar object. Public announcement is delayed pending further astrometry. August 12, 2025, 3:30 Universal Time Coordinated. First JWST observation of 3I/Atlas completed. Initial spectra show strong CO2 features and weaker than expected H2O. September 5, 2025, 6:15 Universal Time Coordinated. Combined U.S. ground-based polarimetry campaign reports an inversion angle around 17 degrees, flagged as unusual compared to typical solar system comets. September 19, 2025, 11:02 Universal Time Coordinated. IceCube detects a 290 TeV neutrino event, later labeled 2550919A, with a reconstructed direction overlapping, within errors, the region of sky traversed by 3I/Atlas. Correlation is noted but not claimed. October 2, 2025, 18:20 Eastern Daylight Time. JPL Orbital Dynamics team circulates a memo noting that backward integrations of 3I/Atlas's trajectory bring it within a small fraction of an astronomical unit from Neptune earlier in the year, with high uncertainties but non-zero probability of even closer approach. October 19, 2025, 2300 hours Eastern Daylight Time. AWS internal monitoring notes small, unexplained increases in DNS latency for US East 1. Alarms remain below paging thresholds. October 20, 2025, 3:11 Eastern Daylight Time. US East 1 experiences a sudden spike in DNS nextdomain errors, followed by authentication failures and DynamoDB timeouts. Major outage begins. October 20, 2025, 7:45 Eastern Daylight Time. Social media in the US fills with #AWSdown posts. Alternative media channels begin speculating about cyber attacks and cosmic coincidences. October 21, 2025, 4:50 Eastern Daylight Time. Final preconjunction JWST observation of 3I/Atlas is received. Science team notes persistent CO2, H2O is almost equal to 8:1 ratio and unconfirmed metallic emission features. October 21, 2025, 2100 hours Eastern Daylight Time. 3I/Atlas passes into solar conjunction from Earth's perspective. Most direct observations cease, initiating a blind window of several weeks. Data blocks, astronomy, JWST spectra, September, October 2025. In a series of observations from early September through October 21, Webb's NRSpec instrument repeatedly measured a CO2, H2O ratio for 3I/Atlas of approximately 8:1 with an uncertainty of about plus or minus 1. For comparison, many long-period solar system comets show ratios closer to 1:1 or 2:1. A high CO2 fraction suggests either an unusually CO2-rich body or surface processes that selectively expose CO2 ice. For the public, CO2-rich sounds abstract. For planetary scientists, it raises questions about formation conditions around other stars and whether this object's interior has ever been significantly heated. Polarimetry, ground-based inversion angle. Observatories in Arizona and New Mexico using polarimeters attached to mid-sized telescopes found that the polarization of light from 3I/Atlas flipped sign at an inversion angle near 17 degrees. This is on the low end of known cometary values, hinting at either unusually compact dust grains or a smoother, less porous surface than average. The measurements are preliminary, but they fed into models that already struggled to reconcile the spectra with standard comet dust assumptions. Metallic lines, unverified rumors of nickel. In late October, a small American online tabloid ran an article citing an unnamed NASA insider claiming that Webb had detected nickel alloy emission lines from 3I/Atlas, suggesting technological materials. No peer-reviewed data support this, and internal emails emphasize the lines are likely artifacts from imperfect background subtraction or instrument noise. Still, the phrase, nickel alloy, was enough to seed countless threads about alien hull plating and engineered objects. Log, AWS US East, 1 outage snippet, log, October 20, 2025 T 3 hours 9 minutes and 58 seconds Z, US East, 1, control, config_push failed. SVC equals auth, db, az3, reason equals lock_wait_timeout, log, October 20, 2025 T 3 hours 11 minutes and 7 seconds Z, US East, 1, DNS, next domain rate equals 0.98 paging SRE, log, October 20, 2025 T 3 hours 12 minutes and 30 seconds Z, US East, 1, LB. Unhealthy_backends equals 82%, initiating_draining. For non-specialists, these lines translate as, a configuration change hit a locking issue, name resolution suddenly began failing for almost all requested domains, and load balancers started removing backend servers from rotation because they looked unhealthy. On their own, they describe a classic cascading failure. In the context of 3i/Atlas, they were reinterpreted by some as evidence of interference. Tweet, Citizen Astrophysics, tweet, October 20, 2025 9:02 Eastern Daylight Time, at @astro_citizen, so we're just gonna ignore that 3i/Atlas is going behind the sun while #UsEast1 is down and JPL whispers about Neptune close passes? Cool. #3iAtlas #Neptune risk. Press, IAA note, Press, IAA, October 22, 2025, current analysis confirms an interstellar trajectory for object 3i/Atlas. Reported anomalies in spectral and polarimetric data are under active review. No credible evidence at this time links 3i/Atlas to terrestrial infrastructure incidents or planetary hazards. We encourage adherence to established verification protocols. Voices, the official scientific line, in the United States at least, remains cautious. We do not see a physically plausible mechanism linking a transient cloud service outage to the motion of an interstellar object millions of miles away, says Dr. Allison Green, a planetary scientist at NASA's Goddard Space Flight Center, when asked for comment by freelance journalist Emma Cole. Green's voice on the phone is steady, clipped. The Neptune pass is interesting in a purely dynamical sense, but the uncertainties are enormous. Anyone suggesting Neptune could explode is not reading the numbers honestly. On another floor in a very different building, Maria Thompson avoids interviews, but her written debrief for the Incident Review Board is direct. The failure began in our control plane during a configuration push, she writes. The subsequent DNS cascade is consistent with internal misconfiguration and lock contention, not an external actor. That said, our customers do not care if the root cause is a line of mistyped JSON or a solar storm. From their perspective, the cloud failed. In Washington, at a closed-door briefing summarized later in a redacted memo, an intelligence analyst with the Defense Intelligence Agency offers a narrower lens. Any time you have a novel space object with uncertain composition and a major U.S. infrastructure incident in the same 48-hour window, our job is to assume correlation until we can safely rule it out, the analyst, identified only as HR, tells assembled staffers. We don't jump to aliens. We do ask, is any adversary exploiting the narrative, or the data flows, for their own purposes? Outside official channels, alternative media hosts seize the overlap. On his late-night webcast from Austin, Texas, host Kyle Bridges leans into the camera and speaks to 500,000 U.S. viewers. They're telling you it's just a coincidence that some mystery rock from another star system buzzed Neptune, maybe messed with its field, and now vanishes behind the sun right when your delivery app dies, he says. The same people who tell you everything is under control in the cloud. Maybe the problem isn't the rock. Maybe the problem is trusting systems we don't control and institutions that don't tell us when a planet might be at risk. Scenarios, in private labs and public threads, for main scenarios now circulate, each shaped heavily by American institutions and narratives. Scenario A is the simplest, coincidence. In this view, the AWS outage is a textbook example of cascading failure in a hypercentralized cloud region, triggered by a bad configuration push and made worse by subtle pre-existing latency issues. 3I/Atlas, meanwhile, is simply following a trajectory set by gravity and its own initial ejection velocity from a distant system. Neptune's close pass sounds dramatic, but the uncertainties and distances involved make catastrophic interaction vanishingly unlikely. The timing, supporters of this scenario argue, is meaningful only to humans looking for patterns. Scenario B frames the outage as a human-made vulnerability, potentially exploited. Here, the cloud incident remains a technical misstep, but adversarial actors, foreign intelligence services or sophisticated criminal groups, latch onto the narrative collision to sow mistrust, inject disinformation, and probe responses. 3I/Atlas becomes a prop in an information operation, not an active agent. Hashtags like #NeptuneRisk and doctored leaked diagrams of Neptune's supposed crack lines are seeded into American social feeds to test how quickly panic can be induced. Scenario C is the most speculative but also the one that energizes a subset of the scientific and defense communities, a genuine, if remote, cosmic risk. The JPL memo on Neptune is at the heart of this. If 3I/Atlas's trajectory did bring it extremely close to Neptune months earlier, close enough that, under some high-mass assumptions, tidal or collisional effects become non-negligible, then the object is not merely an academic curiosity. Even if Neptune shows no visible damage, the scenario forces uncomfortable questions about our ability to detect and characterize rare, high-impact events in the outer solar system. In this framework, the AWS outage is still coincidence, but it occurs in a moment when U.S. agencies are already on edge about spaceborne risks. Scenario D, finally, belongs mostly to the fringes, a deliberate techno-signature or engineered object. Here, the high CO2 ratio, the polarimetric anomalies, the rumored metallic lines, and the Neptune pass are read as clues to an artifact, a probe or weapon passing through our system. The cloud outage is interpreted as either caused by the object's passage or by covert experiments to interact with it. Serious scientists dismiss this scenario as unsupported. Yet in American online culture, where UFO hearings in Congress and declassified videos of unidentified aerial phenomena have already normalized certain forms of speculation, scenario D finds an eager audience. Policy, infrastructure, and first recommendations. Within the United States, the immediate policy discussions sparked by the two vanishings focus less on aliens and more on resilience. The AWS incident exposes, yet again, how concentrated critical services are in a handful of regions. A draft staff report circulating in the House Committee on Energy and Commerce suggests new guidelines. Federal agencies should avoid single-region dependencies for essential services. Hospitals using cloud-based electronic health records must maintain offline fallbacks, and regulators should push for clearer outage postmortems from major providers. For space infrastructure, NASA and the National Science Foundation begin exploring how to reduce observational blind zones during solar conjunctions for high-priority targets. Concepts that had lingered on whiteboards, small telescopes in heliocentric orbits offset from Earth, piggyback instruments on commercial satellites, and more aggressive use of U.S. assets like the Deep Space Network, are suddenly framed as tools not only for science, but for planetary situational awareness. In parallel, think tanks in Washington call for a clearer domestic implementation of the no reply clause. If 3I/Atlas continues to show unexplained features once it re-emerges from conjunction, who in the United States decides whether to frame them publicly as natural oddities or possible techno-signatures? A NASA director? A White House science advisor? A joint interagency group that includes defense and intelligence voices? The answers affect not just how Americans perceive the sky, but how they perceive the institutions that interpret it. Open conclusion: in the early hours of November 8, 2025, the screens in Northern Virginia show green more often than red. U.S. East 1 has recovered. New guardrails for configuration pushes are being tested in simulated drills. In Baltimore, the JWST team waits for the geometry of the solar system to shift enough that 3I/Atlas might be glimpsed again, even indirectly, in scattered light or with help from American radio telescopes watching the corona's edge. Somewhere on a JPL server, orbital integrations continue to run, each line of output another small update to the uncertainties around Neptune's near miss. For people like Maria and Michael, the story is still mostly numbers, error budgets, sigma levels, Monte Carlo runs. For most Americans, it has already become something else, a story told on podcasts during commutes, a frightening headline half remembered from a news segment that ran between campaign ads, a meme showing a glitching cloud icon swallowing a blue planet labeled Neptune. Two vanishings, a region of the cloud and a rock from another star, have temporarily overlapped in time and in the American imagination. Whether they stay separate in the official record will depend on what the next data shows, and on who controls their interpretation. Until 3I/Atlas steps out from behind the sun, the United States is, in a sense, listening to a cosmic symphony with one ear pressed against the speaker and the other distracted by the hum of its own machines. Somewhere beyond that glare, an object that may have brushed past Neptune continues on a path our equations can trace but not feel. Down here, the question that remains is less about what it is, and more about what our systems, scientific, digital, political, will do the next time two vanishings line up on the same calendar. Appendix, Selected Technical Snapshot, U.S. Context, 3I/Atlas, Interstellar Designation confirmed July 2025, Inbound velocity consistent with extrasolar origin, preliminary backward integration suggest a close approach to Neptune's orbit earlier in 2025 with large uncertainties. JWST, multiple NRSpec runs from October 2025 show CO2, H2O is almost equal to 8 to 1 plus or minus 1, unusual but not impossible for a cometary body, further calibration pending post-conjunction. Polarimetry, U.S. ground-based measurements indicate inversion angle is almost equal to 17 degrees, hinting at atypical dust or surface properties. IceCube, Event 2550919A at -290 TeV recorded September 19, 2025, with directional overlap to 3I/Atlas region but statistically consistent with background. AWS US East 1, outage window centered around 3:11 to 10:45 Eastern Daylight Time, October 20, 2025, root cause under review, with early evidence favoring internal misconfiguration over external attack. Forensics in the blind window after the first wave of panic subsided, a quieter, more meticulous rhythm replaced it. Across the United States, engineers, scientists, and analysts began doing what they do best, reconstructing the past from logs, timestamps, and data fragments. The immediate public narrative, a cosmic coincidence, had already hardened, but inside labs and incident rooms the work was forensic, patient, and at times disturbingly inconclusive. The story of the outage and the vanishing comet had turned from sensation to investigation. The first step was to understand exactly how a modern cloud, the most complex engineered organism on Earth, could lose its heartbeat. AWS internal postmortem, never meant for public release but later summarized in congressional briefings, described a cascade that began in the control plane of US East 1. Control planes manage configuration changes across thousands of services. At 03 to 09 to 58Z, an automated configuration push encountered a lock_wait_timeout in the authentication database located in availability zone AZ3. This caused a backlog of uncommitted transactions. When the same configuration attempted to propagate, DNS resolvers in the region began to misinterpret failed queries as non-existent domains, spiking next domain errors. Within 2 minutes, load balancers declared 82% of backends unhealthy, initiating draining. This domino effect led to widespread service unavailability. External monitors such as Thousand Eyes and Kentic showed near-simultaneous packet loss in Virginia peering points, confirming that the failure was internal, not due to external DDoS. Yet the human imagination resists pure coincidence, and because the timing overlapped with the 3I/Atlas conjunction window, every log line carried narrative weight. Analysts at the Department of Homeland Security's Cybersecurity and Infrastructure Security Agency, CISA, joined the review. Their focus: indicators of compromise, or IOCs. Did any unauthorized API calls occur in the minutes preceding the outage? Were there anomalies in SSH key usage, persistent connections from unknown IP ranges, or suspicious changes in DNS records? Their findings, later leaked to journalists, pointed to a clean slate, no evidence of intrusion, no anomalous traffic patterns. Instead, the failure bore all the hallmarks of a systemic self-inflicted wound: configuration propagation under load, insufficient rollback granularity, and human fatigue. One internal engineer's Slack message summed it up: the system was too tightly coupled. It's like pulling one thread and watching the whole sweater disappear. Still, absence of evidence is not evidence of absence, and so every subsystem was audited. Control plane logs showed consistent hash sums, indicating no tampering. BGP route announcements remained stable throughout the event, refuting any notion of cable disruption at that moment. The post-mortem's final note, written by Maria Thompson, was concise: root cause, missequenced configuration deployment. Contributing factor, lock contention. Corrective actions, staggered rollout protocol. But even in technical closure, unease lingered. Meanwhile, the physical backbone of America's Internet, the network of fiber optic cables and undersea arteries that connect continents, underwent its own inspection. In early March 2025, months before 3I/Atlas captured headlines, two Mediterranean cables had been damaged, the AAE-1 and the Italy-Greece subsea links. Back then, the cause was ruled accidental, anchor drag. Now, revisiting those OTDR, optical time domain reflectometer, traces, engineers saw nothing inconsistent with mechanical damage. The reflection spikes appeared at 124 kilometers offshore, attenuation jumps characteristic of a steel anchor impact. Still, the repairs had rerouted traffic temporarily through North Atlantic pathways, creating subtle shifts in latency visible to anyone analyzing BGP updates months later. When plotted on a global latency heat map, these routing detours formed what one researcher described as digital weather patterns. They reminded the public that the network's resilience was not infinite. The forensic teams noted that although the October 20 outage did not involve cable faults, the earlier incidents underscored the fragility of the infrastructure under stress. "Every reroute is like a scar," wrote a technician from Verizon in a private email. "We heal fast, but not without marks." While fiber engineers traced light pulses under oceans, astrophysicists peered into digital skies. The Space Telescope Science Institute initiated a comprehensive reprocessing of JWST data related to 3I/Atlas. In forensic science, calibration is everything. Raw frames from an IRSpec are meaningless until corrected for instrument response, dark current, cosmic ray hits, and residual atmospheric interference. Teams at Johns Hopkins and NASA Goddard ran multiple pipeline iterations using different correction sets to rule out instrumental artifacts. The spectral ratio of CO2, H2O remained stubbornly high at around 8:1. This was not a calibration fluke. The feature persisted across exposures, detectors, and pointing angles. But a more mysterious problem arose when analysts compared spectra across time. A subtle shift in the 4.3 micron CO2 band center suggested compositional layering, perhaps outgassing from deep fissures as the object rotated. Or, if one believed wilder interpretations circulating on Reddit, something internal generating heat. Polarimetry teams double-checked their inversion angle results. At 17 degrees, 3I/Atlas's scattering behavior did not fit conventional comet dust models. Using Mie scattering simulations, they attempted to reproduce the data with various grain size distributions and refractive indices. None matched perfectly. "We're looking at a surface we don't fully understand," admitted Dr. Jason Liu from the University of Arizona. "It's not metallic. It's not icy in the usual way. It's muted. Smooth. Maybe sintered dust that's been irradiated for millions of years." Then came the most contentious question: Neptune. At JPL's Center for Near-Earth Object Studies, orbital dynamicist Susan Hernandez led a small group reanalyzing 3I/Atlas's trajectory using refined astrometry. Their backward integrations indicated a passage through the outer solar system months earlier, possibly within a few million kilometers of Neptune's orbit. The uncertainties were large, but non-zero. Simulations exploring mass assumptions from 10 to 12 to 10 to 15 kilograms showed negligible gravitational influence on Neptune's orbit, yet under extreme density hypotheses, say, a metal-rich fragment, tidal interactions could, in theory, generate detectable signatures. The media twisted this into Neptune could explode. Hernandez was furious. "That's not what we said," she told a science blogger. "Neptune is fine. The worst-case scenario is some atmospheric perturbation orders of magnitude below detection thresholds." But the phrasing stuck, and #NeptuneRisk remained among US Twitter's top trends for 3 days. The forensic synthesis soon reached the correlation analysis phase. Statistically, the overlap between a major cloud outage and a celestial conjunction within a 48-hour window felt uncanny. Data scientists at MIT and the RAND Corporation collaborated on a joint probability assessment. They began by estimating the baseline frequencies, large-scale AWS regional outages, roughly 5 per year globally, interstellar object solar conjunctions, approximately 1 every 5 years given the small sample. Multiplying probabilities gave a naive estimate of 1 overlap per 25 years. But factoring in the trial effect, the many events happening constantly across digital and cosmic systems, the probability rose substantially. "Coincidences are the default in a complex universe," said Dr. Rebecca Alston, a statistician involved in the study. "The human brain treats simultaneity as causation, but mathematically, coincidences pile up all the time." Their conclusion: the apparent timing was within expected coincidence limits. No causal connection could be statistically supported. Yet intelligence agencies looked at timing differently. For them, correlation was a trigger, not a verdict. Within the Pentagon's Defense Intelligence Analysis Directorate, analysts reviewed whether any signals intelligence (SIGINT) data coincided with the AWS outage. Dual-use technologies, the same sensors that watch for radio emissions from space and electronic warfare signals on Earth, often overlap. A classified memo later summarized the result: no anomalous radio bursts, no unaccounted transmissions in relevant frequency bands. Nonetheless, the event was flagged for awareness under protocols that bridge NASA's Planetary Defense Coordination Office and national security elements. The logic was simple: when something unexplained occurs simultaneously in cyberspace and outer space, assume adversaries are watching how you respond. Behind the walls of government, the phrase dual-use domain awareness began appearing in policy drafts, shorthand for integrating astronomical monitoring with cyber incident tracking. In civilian science, a different integration was underway. Citizen observers across the United States, using low-cost telescopes linked by open-source software, had joined the 3I/Atlas watch earlier in the season. Their networks, coordinated through a platform called Skylinker, provided time-synced polarization and photometric data. After the conjunction blackout, these amateurs became the fallback layer, scanning for possible re-emergence. Simultaneously, independent data scientists began applying quantum-inspired algorithms to the publicly released JWST spectral sets. Using annealing-based optimization on cloud quantum simulators, they searched for subtle periodicities or hidden emission features. One analysis claimed a weak but repeating microstructure in the 4 to 5 micron band, hinting at coherent emission, a phrase that lit social media like gasoline. NASA swiftly clarified that the pattern was consistent with instrument dither noise. Still, the experiment demonstrated the democratization of data. A single citizen with a laptop and access to AWS, ironically the same platform that had failed days earlier, could now analyze space telescope data once reserved for institutional teams. The speed of analysis came with costs. Machine learning pipelines, trained to flag anomalies, sometimes amplified them. As one AI researcher quipped, "You tell the system to find weirdness, it'll find you weirdness even in white noise." The interplay between public curiosity and machine inference became a feedback loop. Every speculative plotline generated engagement, which generated new discoveries. As November progressed, an uneasy equilibrium settled over the American scientific community. Evidence was being organized into what internal memos called a likelihood matrix. Coincidence, rated high probability. Routine technical failure, high. Opportunistic exploitation, medium. Cosmic causal link, low. The decision framework followed Occam's razor: prefer the simplest explanation consistent with facts. Forensic logic favored internal misconfiguration for the cloud and routine interstellar behavior for 3I/Atlas. Yet even those assigning low to cosmic causation admitted a strange discomfort: the timing, the persistent CO2 anomaly, the public fixation on Neptune. It all felt orchestrated, if not by intelligence, then by narrative gravity itself. Inside NASA, teams debated whether to preemptively draft a reassurance statement for when 3I/Atlas reappeared from behind the Sun. Some argued that silence would breed conspiracy, others, that premature statements risked feeding it. "If we speak too soon, we become part of the story," said one internal email. "If we wait, we look like we're hiding something." At the same time, AWS executives faced congressional questions about systemic risk. Why were so many critical services still concentrated in one region? Could the U.S. enforce diversification across multiple cloud providers without stifling innovation? Engineers testified under oath, describing fault-tolerance architectures, while representatives asked whether solar activity could crash the Internet. The transcript reads like a clash of languages: technical precision against political theater. For every latency propagation, there was a "so you're saying the sun broke Amazon?" The deeper insight emerging from these hearings was cultural. Americans wanted someone to blame, not something to understand. The Defense Advanced Research Projects Agency, DARPA, quietly launched a pilot program labeled Project Heliosync, aimed at correlating terrestrial network anomalies with space weather and astronomical events. Officially, it was about predictive maintenance. Unofficially, it reflected a growing anxiety that digital and cosmic domains were no longer separable. "The same electromagnetic spectrum runs through both," one defense contractor remarked. "Maybe one day we'll learn it's the same battlefield." By the second week of November, partial telemetry hinted that 3I/Atlas would soon emerge from conjunction. Small variations in solar corona images suggested a faint moving source consistent with the predicted ephemeris. Teams in the U.S. prepared to reacquire it. Anticipation mingled with dread. If the spectral anomalies persisted, debates over their meaning would reignite instantly. If they vanished, skeptics would claim data suppression. Either way, trust would be tested. On the cultural front, citizen scientists continued to push boundaries. A group calling itself Open Sky Initiative developed a distributed radio array using synchronized GPS timestamps across backyard antennas. Their initial data, posted online, claimed to capture RF flickers correlated with the last known position of 3I/Atlas. Professionals dismissed it as interference from geostationary satellites. Still, the dataset circulated widely, becoming the first open-source SETI experiment to trend on American social media. Parallel to that, AI startups began marketing anomaly-as-a-service products, promising to detect the next 3I/Atlas-like event before official agencies. The commercialization of cosmic curiosity had begun. Meanwhile, journalists like Emma Cole found themselves caught between technical experts and the viral imagination. Her feature in The Atlantic, titled "The Blind Window," argued that the real crisis was epistemic, when two domains, the digital and the cosmic, fail at once. Our trust collapses into speculation. We fill the silence with stories because the alternative is admitting how little we control. Her piece cited experts from AWS and NASA, but also sociologists studying how information cascades mirror infrastructure cascades. The parallels were striking: a failed lock in a database and a failed lock in public trust. Late in the month, a declassified memo from the U.S. Office of Science and Technology Policy surfaced through FOIA requests. It recommended forming a joint Space Cyber Coordination Council to address exactly these overlaps. The document included a striking line: as observational and computational domains converge, future incidents may blur the boundary between natural and engineered phenomena. It was bureaucratic poetry, but to those who had watched dashboards turn red and comets disappear, it felt true. On November 8, 2025, the day Americans expected a first post-conjunction update, the JWST control team issued a terse bulletin: tracking solutions updated, reacquisition window to open November 12. For the public, that was enough to relight every theory. For investigators, it meant the forensic phase was nearly done. They had dissected the outage, recalibrated the spectra, mapped probabilities, and still the mystery refused to close. In a final interview before moving to a new assignment, Maria Thompson reflected on the months of sleepless nights. "People think technology is exact," she said. "It's not. It's full of timing edges, races, invisible dependencies. Space is the same: it's not a clockwork, it's a probability field. Sometimes two things line up just right to remind you how fragile the sync really is." Her words echoed through the scientific community, uniting programmers and astronomers under a single metaphor: synchronization, the harmony that keeps systems aligned until something slips. As America waited for 3I/Atlas to reappear, the investigation had achieved clarity in facts but uncertainty in meaning. The cloud failed because of a lock. The spectra showed excess CO2. Neptune survived untouched. And yet, the feeling persisted that a larger synchronization failure loomed, not between servers or planets, but between evidence and belief. That sense would carry the story into its next phase, when scientists, politicians, and citizens would all try, in their own ways, to decide what truth looks like when the data runs out. The echo chamber of the sky and the cloud. By the second week of November 2025, the American conversation about 3I/Atlas had escaped the confines of science and settled into politics, media, and faith. What began as a technical coincidence had become a cultural event. The blind window, the period when the interstellar object hid behind the sun and the world was left to imagine, was ending, but the imagination had already done its work. On November 12, at 8:45 Eastern Time, JWST's instruments attempted their first reacquisition scans, hunting for faint infrared traces near the object's predicted re-emergence point. Results would take hours to downlink, and those hours, in 2025's America, were an eternity. In Washington, reporters gathered outside NASA headquarters waiting for any statement. Inside, spokesperson Daniel Keene rehearsed three versions of the same line, adjusted only by tone. Version A, reassuring, technical, calm. Version B, cautious but confident. Version C, vague, defensive, safe for an administration that could not afford another, unknown, crisis. At 11 o'clock Eastern Time, the official press briefing began. "Our teams have completed the initial scan sequence for 3I/Atlas, Keene read, and preliminary data suggest reacquisition is consistent with orbital predictions. Further spectral analysis is underway. There is no evidence of planetary hazard to Neptune or any other body in the solar system." It was a textbook statement, factual, dry, and instantly unsatisfying to an audience that had already tasted drama. Within minutes, networks ran Sheeran's reading: "NASA confirms Atlas still there, but questions remain." Cable anchors replayed old graphics showing Neptune glowing blue and fragile, as if awaiting judgment. In Congress, the House Committee on Science, Space, and Technology demanded transparency. Representative Laura Mendez of California, flanked by aides with printouts of social media posts, called for an emergency hearing. When a federal agency tells the public "no danger" without releasing full data, they invite speculation, she said. If this object brushed Neptune, the American people deserve to know what we saw. Across the Atlantic, the European Space Agency issued its own statement that afternoon, slightly more technical, photometric reacquisition confirmed. Spectral integrity under review. No significant gravitational perturbations recorded. On international networks, the phrasing "under review" was interpreted as "unconfirmed anomalies persist." Within 24 hours, speculation had globalized. In Beijing, the China National Space Administration announced its LISA Pathfinder array had recorded background electromagnetic disturbances during the conjunction period, though it attributed them to solar wind fluctuations. Russian state media, sensing opportunity, aired a segment implying the Americans were hiding a cosmic military test. The hashtag Neptune risk, after fading, spiked again. United Nations channels began to stir. The Committee on the Peaceful Uses of Outer Space, COPUOS, convened an emergency session on November 14 in Vienna. Delegates from the US, EU, China, Russia, and Japan attended virtually. The agenda was concise but loaded: review of interstellar object monitoring, coordination and assessment of potential systemic vulnerabilities revealed by the October incident. The meeting minutes, later leaked, read like a dance of diplomacy and distrust. The U.S. delegate, Dr. Karen Wolf, emphasized transparency and cooperation. 3I/Atlas is a scientific object, not a geopolitical one. The Chinese delegate, Zhang Wei, pressed for access to JWST raw data under international scientific sharing protocols. The Russian representative suggested that any selective data withholding would violate the spirit of the Outer Space Treaty. Behind the polite phrasing, the subtext was clear: whoever controlled the narrative of 3I/Atlas controlled the credibility of planetary observation itself. Meanwhile, back in the US, the public stage grew louder. Talk shows filled airtime with pseudo-experts and legitimate scientists forced into impossible sound bites. Could Neptune explode? A host asked on a morning show, to which a planetary physicist sighed and replied, "No, that's not how planets work," before being cut off for a commercial about anxiety medication. On YouTube and TikTok, citizen analysts broke down orbital diagrams with bright arrows and ominous music. One video titled "They Lied About Neptune" hit 6 million views within 2 days. By the time the first peer-reviewed data from JWST's post-conjunction observations reached servers in Baltimore, the digital narrative had already outrun it. At the Space Telescope Science Institute, Dr. Michael Reyes and his team finally confirmed what the new spectra showed: the CO2-H2O ratio was decreasing toward 4:1, still unusual but trending closer to comet-like behavior. The polarimetric anomalies persisted but showed variations consistent with rotational effects, not structural change. In short, the object was stable, natural, and inert. Yet the press release, when published, failed to move the needle. Public interest had migrated from "what is 3I/Atlas" to "who decides what it means." The gap between data and interpretation had become a political battlefield. On November 15, the White House issued its first coordinated statement through the Office of Science and Technology Policy. The United States reaffirms that the object designated 3I/Atlas poses no threat to Earth or Neptune. Our analysis continues in collaboration with international partners. The recent AWS outage remains unrelated to any celestial activity. That sentence, intended to close the matter, reignited it. Online commentators seized on the phrase "remains unrelated" as bureaucratic evasion. "If you have to say it's unrelated, it probably is," tweeted one conspiracy influencer with 1.2 million followers. Overnight, #Atlas cover-up began trending alongside #blind window. Late-night host Jimmy Fallon joked, "So the government says an alien rock didn't blow up Neptune or the internet. Cool, I feel totally reassured." Laughter filled the studio, but the unease beneath it was real. Think tanks began publishing analyses treating the event as a case study in communication failure. Rand's report, Signal in the Noise, Managing Public Perception in Dual-Domain Events, argued that simultaneous infrastructure and astronomical incidents create fertile ground for misinformation when institutional responses lack narrative coordination. The Brookings Institution's policy brief warned that scientific transparency, not censorship, is the antidote to conspiracy. Both reports reached congressional inboxes but made little immediate impact. Meanwhile, in Geneva, the UN subcommittee drafted a non-binding resolution urging member states to establish standardized communication frameworks for cross-domain anomalies. The vote was unanimous, though skeptics noted that standardized communication often meant more control, not more clarity. On November 18, NASA held a live press conference featuring Dr. Allison Green from Goddard and Dr. Susan Hernandez from JPL, the same scientists previously quoted in leaked memos. The event aimed to restore confidence. There is no evidence of any interaction between 3I/Atlas and Neptune, Hernandez said firmly. All gravitational models show stability. The object's current trajectory leads it out of the solar system over the next 6 months. Green added, "We have reprocessed all JWST data through independent pipelines. The CO2 ratio anomaly is real but within natural variability. We are looking at a unique but not unprecedented body." Reporters asked about the AWS outage. "Separate incident," Green repeated. But outside the building, protesters held signs reading, "We deserve truth," and "Neptune is blue, why are you lying?" It was no longer about science, it was about belief. The following day, the Senate Intelligence Committee held a closed briefing on potential exploitation of astronomical events in information operations. Though classified, snippets emerged, discussions of Russian troll activity, Chinese bot networks, domestic extremist groups using #NeptuneRisk memes to spread anti-science sentiment. "This is not just misinformation," said one senator afterward. "It's weaponized coincidence." Across the U.S., the media war intensified. CNN aired a documentary titled "The Object and the Outage." Fox News countered with "clouds, comets, and cover UPS." Social media splintered into factions: the skeptics, the believers, the pragmatists. Reddit's r/astronomy mod team published an open letter, "Please stop asking if Neptune is gone. It's literally visible." Meanwhile, local observatories saw a record attendance for public viewing nights. Parents brought children to see Neptune through telescopes, as if to confirm with their own eyes that the planet still existed. "It became a ritual of trust," wrote journalist Emma Cole in a follow-up essay. Americans looked through telescopes not to see space, but to believe it hadn't lied. Amid the noise, a handful of genuine breakthroughs occurred. The NASA Open Data Initiative, under pressure from Congress, released anonymized versions of 3I/Atlas spectra and polarimetry sets. Citizen scientists quickly confirmed the main findings: high CO2 content, no metallic lines, stable orbit. The act of transparency diffused some tension. But other groups twisted the data release into new conspiracies. "They're giving you fake files," one viral post claimed. "The real data is classified under Project Heliosync." In truth, Heliosync was the DARPA pilot program correlating space and cyber incidents. But secrecy breeds myth. When an anonymous whistleblower leaked a slide deck showing cross-domain incident correlation, case study, October 2025, the public saw only what it wanted: government confirmation that something linked the comet and the cloud. The slide, stripped of context, spread across forums. Within hours, journalists were asking if the U.S. military had detected signals from 3I/Atlas. The Pentagon denied it. The narrative refused to die. Internationally, tensions mirrored America's. The European Parliament debated a resolution calling for cosmic transparency, demanding NASA share raw JWST telemetry. In China, state-controlled media accused Western scientists of hiding interstellar materials. Russian commentators proposed that the U.S. was testing solar deflection systems. The sky, once a shared wonder, had become contested territory in an information war. The irony was not lost on scientists: the more they measured, the less they were believed. On November 20, Copuos released its preliminary findings. 3I/Atlas exhibits no known properties inconsistent with natural cometary bodies. Member states agree on continued observation. No threat to Neptune or Earth detected. But in the US, the public conversation had moved to another stage: accountability. Congressional committees summoned AWS executives and NASA administrators for a joint hearing titled Vulnerabilities Across Domains. Maria Thompson, reluctantly testifying, described the outage's root cause again in plain terms: a mistimed configuration update caused DNS cascade failures. No cyber attack. No external interference. The timing overlap was coincidence. A congressman interrupted: "Are you saying a single mistake by one engineer can take down half the country?" "Not half the country," Maria corrected, "but enough to remind us how fragile our systems are." The quote went viral. Within hours, it appeared in memes showing Maria's face over a starfield with the caption, "Enough to remind us how fragile we are." It became the unofficial epitaph of the October events. As hearings dragged on, think tanks proposed reforms. The Center for Strategic and International Studies recommended mandatory multi-region redundancy for critical cloud services. The Federation of American Scientists urged creation of a Space Transparency Act requiring public data release for all interstellar observations. The White House quietly formed a task force, the Space Cyber Coordination Council, echoing the leaked OSTP memo. Its mandate: to ensure coherent communication and resilience in simultaneous cosmic and digital events. The council included representatives from NASA, NOAA, CISA, and the Department of Defense. The first meeting took place under fluorescent lights in a windowless room, the same kind that had witnessed the initial AWS crisis weeks before. Participants agreed on one thing: the boundary between infrastructure and observation was gone. Around the same time, new data from the Deep Space Network confirmed 3I/Atlas's outbound trajectory. It was receding from the Sun at expected velocity, showing weak CO2-driven outgassing but no anomalies. Neptune remained undisturbed. The final NASA bulletin read: "Observation complete. Object exiting heliocentric visibility zone. No residual hazards detected." The press barely covered it. The story's dramatic arc had ended quietly, but the social aftershocks continued. Universities launched courses on science communication in the age of conspiracy. Social psychologists studied the two vanishings as a model for how societies process simultaneous crises. One paper in Science described the event as a dual failure of infrastructure and epistemology. Another in Foreign Affairs warned: if the next anomaly involves something truly dangerous, trust may not survive long enough to act. On November 23, Emma Cole published her final feature, When the Lights Blinked and the Stars Hid. In it she wrote, "The danger was never Neptune's explosion or an alien signal. The danger was discovering how thin the membrane of belief had become." For 48 hours, the most connected nation on Earth realized it could not tell whether its silence came from space or from its own machines. Her article went viral, quoted by senators and skeptics alike. Even Maria Thompson sent her a brief message: "You got it right." Across the world, similar reflections emerged. The BBC called the October events the first epistemic crisis of the AI astronomy era. In Japan, an editorial titled "When Clouds and Comets Collide" argued for a new global architecture of trust. In Washington, the Space Cyber Council drafted recommendations that would later shape policy. 1. Distribute critical infrastructure across providers and geographies. 2. Mandate transparent postmortems for major outages. 3. Establish real-time data sharing among space agencies during cosmic anomalies. 4. Create public dashboards to prevent vacuum of information. 5. Reinforce education against misinformation. Each point read like a SCAR's instruction manual. Yet, even as bureaucracy advanced, culture lagged behind. On social media, fringe theories endured. A year later, polls would show that 28% of Americans still believed 3I/Atlas carried unknown technology, and 14% thought the Neptune incident was partially classified. The facts had been clear for months, but the myths were immortal. As November waned, a small ceremony at NASA's Goddard Space Flight Center marked the end of the observation campaign. Dr. Allison Green stood before a group of tired engineers and scientists. "We did our job," she said softly. "The data holds. The planet stands. The cloud runs. But maybe the next time something crosses our sky, we'll spend less energy fighting ourselves." Applause followed, subdued but sincere. Outside, the autumn sky over Maryland was clear. Neptune, invisible to the naked eye, continued its orbit undisturbed, blue and indifferent. The final NASA blog post, written by Reyes, captured the tone of weary closure. 3I/Atlas reminds us that the universe is vast, data is fragile, and coincidence is not conspiracy. We study, we verify, we learn. But even that post became the subject of debate. Some praised its humility, others mocked its simplicity. The story refused to end neatly because America itself no longer ended stories neatly. Everything looped back into feeds, into interpretations. The last flare came from an unexpected place, a small open-source observatory in Kansas, part of the citizen network Skylinker, released its own independent detection of 3I/Atlas's outbound light curve. Their conclusion: no residual anomalies. The post went mostly unnoticed, buried beneath a trending celebrity scandal. And so the greatest cross-domain investigation in years faded quietly into archival servers. In retrospect, historians would divide the two vanishings into phases: shock, analysis, politicization, and forgetting. Yet something had shifted. The October 2025 coincidence had revealed the seams of trust in a technologically entangled world. Engineers saw how a mistimed configuration could cascade through economies. Scientists saw how a single ratio in a spectrum could spark existential fears. Citizens saw how silence could sound like conspiracy. Governments saw how even truth, without timing, could lose credibility. In the end, 3I/Atlas left no crater, no signal, no wreckage, only questions. What happens when data and belief diverge? How do we keep systems synchronized, not just in code but in understanding? And if someday a signal truly comes, from space, from nature, from ourselves, will anyone still believe it? The answer, like the comet itself, was already receding into the dark, its trail fading behind the sun, while down on Earth the glow of servers and headlines continued, restless and unblinking. Inside the systems of silence in the weeks that followed the fading of 3I/Atlas into the outbound dark, America's attention turned from the public theater of hearings and hashtags to the quiet, fluorescent-lit rooms where actual investigations continued. What the public didn't see were the internal emails, the conference calls, and the guarded exchanges between NASA, DARPA, and the intelligence community, each now circling the same question from opposite sides: had something been missed, and who would decide what counted as missing? The opening of the fourth phase began with a message timestamp December 1, 2025 t 8 hours 13 minutes and 4 seconds Z, internal to NASA's Goddard Network, RE, post-analysis residuals in JWST-NIR spec 4.2 to 4.5 micrometers band. Suggest review for instrument-related versus source-related asymmetry. It was sent by Dr. Michael Reyes to Allison Green with a simple note: we should double-check before the Hill starts asking again. Within hours, the file was duplicated into DARPA's HeliaSync repository, the joint project that had quietly expanded from a pilot into a standing coordination group. HeliaSync's charter was vague: to identify cross-domain anomalies in the electromagnetic spectrum and compute infrastructure, but its internal memos read like early drafts of an American doctrine of cosmic cybersecurity. Inside the agency's windowless rooms, analysts ran parallel investigations. One team dissected the AWS outage again, comparing timing precision with the cosmic dataset. Another reviewed space weather logs, searching for microbursts or radio scintillation that might have coincided with the DNS failure. A third focused on pattern detection, using neural correlation systems trained to match anomalies across domains. The conclusions were consistently inconclusive. The logs aligned too neatly to prove or disprove causation. Every explanation seemed to dissolve into the noise. Yet within NASA's Science Directorate, tension simmered. Engineers wanted to close the case scientifically: a misconfiguration on Earth, an interstellar rock in space. Administrators, under quiet pressure from the National Security Council, preferred ambiguity. The reasoning was simple: if a public cannot handle coincidence, it cannot handle uncertainty either. Internal research divisions, astrophysical data systems, SETI liaison teams, planetary defense officers, found themselves rewriting documents with careful euphemisms: non-correlated events, statistically independent phenomena, no causal linkage identified to date. To the scientists, the phrasing was bureaucratic anesthesia. To policymakers, it was containment. But beneath those edits, a deeper conflict was brewing. In December, a series of internal workshops convened at the Johns Hopkins Applied Physics Laboratory to analyze the remaining technical questions. The first sessions were routine: spectral calibration, instrument drift, cross-validation with ground-based telescopes, but by the third, the tone shifted. A visiting physicist from Caltech, Dr. Adrian Lambert, presented a reanalysis suggesting that the CO2 spectral asymmetry could indicate embedded micrograins with unusually high reflectance, possibly metal oxides. The word metallic triggered a cascade of questions. Within hours, someone copied the draft slide deck into a shared government folder labeled Sensitive, Heliosync Review. The next morning, that folder's access logs showed 8 unique users from different agencies. Within 3 days, the story leaked to a fringe online publication claiming NASA confirms metallic particles IN3I/Atlas. The leak forced an emergency teleconference between NASA's administrator, the Secretary of Defense, and the White House science advisor. The transcript, later redacted and released through FOIA, recorded one of the most tense exchanges of the investigation. "We can't classify spectra," said Green. "They're public by design." "Then stop calling them metallic," replied an official voice marked only as DoD liaison. "Use high albedo inclusions. The word matters." That small linguistic battle captured the entire fracture line between science and security. In parallel, DARPA's own analysis group within Heliosync went further. Using quantum annealing pattern recognition on the outage data, they identified what they called temporal harmonics, microsecond-scale timing regularities between the AWS DNS failures and the initial drop in JWST telemetry. Mathematically, it could be random coincidence. Operationally, it looked like sync drift. The internal notes summary line read, "Not causal, but suspiciously resonant." That phrase, suspiciously resonant, became a ghost haunting the subsequent months. Green dismissed it as statistical overfitting. DARPA's engineers called it signal. The tension reached its peak during a classified meeting at Fort Meade, where NASA and intelligence representatives sat side by side reviewing overlapping datasets. A technical officer from the NSA explained that their passive spectrum monitors had, in fact, recorded an unexplained broadband spike at 3:11 Eastern Time, the exact minute the AWS outage began. But he cautioned it was consistent with solar flare noise, not communication. "It's the sun," he said flatly. "It's always the sun." Still, someone in the room asked, "What if it wasn't?" From that moment, the investigation split into 2 quiet camps. The scientists doubled down on instrument diagnostics, publishing new calibration reports and refining orbital data until no trace of anomaly remained. The defense sector treated the coincidence as a rehearsal, a demonstration of how narrative vulnerabilities could destabilize a nation even without an attack. "If you can't tell whether the universe glitched or your network did," read one classified summary, you've already lost control of reality. Meanwhile, within NASA, a smaller and more personal conflict unfolded. Michael Reyes found himself increasingly isolated. His insistence on open data had made him a media favorite but an internal risk. In late December, he was reassigned to an advisory capacity. His private emails, later leaked by a sympathetic colleague, reveal growing frustration. We're treating data like contagion. Everyone wants containment, not understanding. If the cosmos whispers in an unexpected frequency, our first instinct shouldn't be to mute it. Green tried to mediate, but even she admitted in her notes, the optics have devoured the science. Outside the agencies, universities took advantage of the chaos to push their own research. MIT launched the Interstellar Forensics Initiative, funded by private donors, to analyze publicly available JWST data. Caltech's Jet Propulsion Laboratory introduced new protocols for anomaly classification. And in an ironic twist, AWS itself funded a research program on resilient synchronization in distributed networks, citing lessons learned from concurrent cosmic and computational events. In January 2026, the first Heliosync cross-domain report circulated internally. Its conclusion was cautious but telling. While no definitive correlation between astronomical and computational anomalies has been established, concurrent timing underscores the need for integrated monitoring frameworks. The event highlights systemic synchronization fragility across technological and observational infrastructures. The key phrase, synchronization fragility, would soon migrate into academic papers, policy briefings, and media sound bites. Inside the agencies, it meant one thing: the systems we trust to interpret the world, both digital and celestial, share common failure modes. For scientists, that was a technical insight. For politicians, it was a warning about governance. The internal disagreements over classification reached a breaking point in February, when a senior DARPA analyst proposed sealing certain datasets under the pretext of potential dual-use technologies. Green objected in a written response: if we classify anomalies, we teach the public that ignorance is safety. That's not science. That's superstition with funding. Her defiance won admiration among her peers but cost her politically. The following week, NASA's communications team announced she would transition to an academic fellowship. Officially, it was a sabbatical. Unofficially, it was exile. By spring, the investigation had metastasized into bureaucracy. The Space Cyber Coordination Council produced thick binders of procedural reforms, multi-cloud redundancy, open telemetry policies, and new space situational awareness protocols. But among the technical annexes were stranger entries: proposals for automated coincidence detection, algorithms designed to flag events that might overlap across physical and informational domains. The systems were intended as early warning tools, but critics warned they risked turning every glitch into a crisis. "We'll drown in false positives," one scientist wrote. "Every solar flare, every DNS hiccup will be a potential incident." The fear was not of aliens or cyber attacks, it was of self-induced paranoia encoded into the infrastructure of observation. The cultural atmosphere reflected that paranoia. Documentaries proliferated. University panels debated the ethics of data suppression. In one memorable exchange at MIT, Dr. Adrian Lambert declared, "The lesson of 3I/Atlas isn't that we found aliens. It's that we discovered our tolerance for ambiguity is lower than our error margin." His quote made national headlines. At the same time, alternative media reframed the same sentiment as confession: NASA admits to hiding ambiguity. The informational feedback loop had become self-sustaining. Inside government, analysts noted with grim fascination how the initial conspiracy about Neptune's destruction had evolved into a self-referential myth about cover-ups and algorithms. The truth was no longer the object, the reaction was. In late March, as budgets were being drafted for the next fiscal year, a confidential policy memo circulated between the Office of Science and the Department of Defense. It recommended establishing a permanent interagency, anomaly coordination office. Its tasks: oversee cross-domain anomaly response, manage communication during data blackouts, and safeguard public confidence. The last phrase, public confidence, was underlined 3 times. Critics saw it as the birth of a new information control regime. Supporters called it pragmatic adaptation. The memo's author, unnamed in the leak, summarized the logic: when trust collapses faster than systems recover, stability becomes a function of narrative latency. In the meantime, 3I/Atlas had faded into numerical abstraction, a set of coordinates drifting beyond the sun's gravitational reach. No telescope on Earth could see it now. But its ghost lingered in policy, research, and even pop culture. Streaming platforms optioned dramatizations. Podcasts serialized the day Neptune almost died. School curriculums added modules on critical thinking during digital blackouts. The object itself was gone, but its reflection in human systems kept amplifying. In April, a quiet internal audit at NASA revealed that during the height of the investigation, one of the auxiliary sensor arrays in the Deep Space Network had intermittently logged faint non-terrestrial signals near the solar limb. The frequencies matched solar radio bursts, but the timing, again, overlapped with the AWS outage period. Engineers dismissed it as correlation without meaning. The audit recommended no further action. Still, someone attached a handwritten note to the file before archiving: it's always correlation until it's not. That file, catalogued as DSN log 2025-10-20 SR, would resurface years later in independent research, cited as the final unresolved trace of the 2 vanishings. By summer, the agencies involved had formally closed the case. Heliosync remained active but rebranded as the Spectral Integrity Program. NASA published its final technical report: 3I/Atlas exhibits compositional and behavioral features consistent with a volatile-rich interstellar object. No artificial properties detected. Event correlation with terrestrial network outage statistically insignificant. It was, by all measures, definitive. Yet inside the scientific community, few believed the closure was final. Definitive, wrote Reyes in his journal, is just bureaucratic for exhausted. As he prepared to leave NASA for a position at MIT, he gave one last lecture to a group of graduate students. What we learned isn't in the data, he told them. It's in the silence between datasets. Systems fail together not because they're connected physically, but because they share assumptions about control. The AWS servers assumed redundancy. Our instruments assumed predictability. Both were wrong the same way. His words circulated among students, quoted online and eventually in think tank reports. The phrase, silence between datasets, entered the academic lexicon as shorthand for the unknowns we overlook when we synchronize too perfectly. The months following the closure were anticlimactic. Neptune continued its orbit, serenely unaffected. The Internet stabilized. Yet, something in the institutional psyche of the United States had changed. Agencies began running coincidence drills, mock scenarios where simultaneous unrelated events tested their communication readiness. The idea was to prevent the next #2vanishings from spiraling into confusion. Ironically, the drills themselves leaked, spawning new conspiracies about predictive rehearsals. Every attempt at control fed the same hunger for uncertainty. By late 2026, congressional oversight committees had stopped asking about the original event, shifting instead to budget justifications. The public forgot, mostly. But among the scientists and engineers who had lived through it, the memory remained: the moment when the sky and the cloud had blinked together, and no one could tell which was cause and which was coincidence. In that memory lay the moral core of the entire saga, a realization that modern civilization's sensory organs, from telescopes to data centers, share the same vulnerability: when they fail in synchrony, meaning itself becomes unstable. The last entry in the Heliosync archive for 2025, logged under a neutral timestamp, reads simply: log, December 31, 2025 T 23 hours 59 minutes and 59 seconds Z, correlation review closed. Awaiting next incident. It carries no author name, no conclusion. Just a final line appended in smaller font, every silence leaves a residue. The next noise it began, as all modern mysteries did, with an anomaly buried deep in the logs. On the night of January 4, 2027, in a small data facility on the outskirts of Palo Alto, a junior systems analyst named Richard Su noticed something he could not immediately categorize: a repeating packet loss pattern on a segment of intercontinental routing that connected NASA's Deep Space Network relay in Canberra to an experimental quantum encryption node in California. It was a trivial technical glitch, but it appeared every 10.8 minutes with clockwork precision, a heartbeat without a heart. Su opened an internal ticket, labeled it low severity, and almost forgot. What he didn't know was that at nearly the same time, the rebranded Spectral Integrity Program, born from Heliosinc's ashes, had flagged faint irregularities in low-frequency cosmic background data, oscillations at nearly identical intervals. When the two datasets were later cross-compared, the timestamp correlation was exact to within a fraction of a second. For weeks, the overlap lay unnoticed. Then, one night, an analyst working remotely from Colorado, cross-referencing packet latencies with astrophysical telemetry, saw the match and sent a message up the chain. The subject line read, "Is the universe pinging us back?" The story of the two vanishings was supposed to have ended long ago, archived, filed, converted into lectures and think pieces. Yet here, suddenly, was another coincidence, too perfect, too symmetrical, arriving 2 years after the first. This time, there was no comet, no outage, no Neptune rumor. There was only a rhythm. The interval, 10 minutes, 48 seconds, was short enough to be measurable, long enough to resist easy dismissal. Spectral engineers at NASA ran sanity checks. Network analysts at AWS, still scarred from the 2025 event, confirmed the packet loss was real but localized. Their internal commentary was cautious: possible routing instability, not reproducible in other regions. Meanwhile, the astrophysicists discovered that their background oscillations were present only in the southern hemisphere data, visible from Canberra but not from Goldstone or Madrid. It wasn't a signal, it was an interference. Except the interference moved, gradually shifting its phase alignment each night, as though following something unseen. The official language of modern science was not built to handle coincidence twice. When the first sync drift happened in 2025, it was explained away with statistics, fatigue, and politics. This one arrived in an era of permanent suspicion. Every government agency, every newsroom, every online conspiracy channel was now trained to hunt for narrative patterns. "We've been here before," one journalist tweeted within hours of the first leak. The silence is always louder the second time. By mid-January, NASA's Public Affairs Office issued a preemptive clarification: recent low-level telemetry variations are under routine analysis. No known correlation exists between network performance data and astronomical observations. It was almost word-for-word identical to the first statement from 2025, and therefore useless. The phrase, "no known correlation," had become meme material. Screenshots of that line flooded social media alongside captions like, "Here we go again." Inside the agencies, meetings multiplied. The Space Cyber Coordination Council, now permanent and far better funded, initiated what they called synchronized domain audit. Their instructions were precise: correlate every dataset across physical, digital, and atmospheric domains for the period January 1 to 15, 2027. The resulting data cloud was enormous: 200 terabytes of time-synced readings from satellites, data centers, weather stations, radio telescopes, and undersea cables. Feeding it into analytic frameworks produced what one engineer called the most complete snapshot of human infrastructure ever assembled. It was also meaningless. The patterns changed depending on how the data was normalized. If you adjusted for latency, the oscillation vanished. If you filtered for power fluctuations, it returned. If you plotted both domains together, they lined up again, mockingly perfect. Somewhere deep in the National Geospatial Intelligence Agency servers, a note appeared in the metadata: recurrent stochastic synchrony observed. The phrase was technically correct and philosophically useless. Scientists at MIT argued over whether the term synchrony even applied. Philosophers at Stanford debated whether repeated coincidences demanded redefinition of randomness itself. Outside the institutions, however, the public did not wait for permission. YouTube channels resurrected the forgotten hashtags: #2vanishings, #NeptuneRisk, #blindwindow. Except now they added a new one: #nextnoise. The word noise spread faster than any official explanation. It meant everything: static, interference, the unexplainable hum of the cosmos, and the lies governments tell when they cannot describe the unknown. In Los Angeles, talk radio hosts asked if the signal was the comet calling back. In London, a viral TikTok claimed to overlay the oscillations pattern with human brainwave frequencies. In Tokyo, artists began composing music timed to the 10-minute rhythm. Conspiracy had become culture. Meanwhile, the Spectral Integrity Program pressed deeper. Its analysts discovered something more disturbing: the pattern's amplitude was not constant. Every 48 hours, the oscillation doubled briefly in intensity, then decayed, like a wave beating against itself. Statistically, it could still be random interference. But the recurrence now had rhythm, not just repetition. That subtle difference forced a new hypothesis: resonance. The very word sent shivers through the old Heliosync veterans. Suspiciously resonant, the phrase from 2025's classified memo, returned in hushed jokes across message boards and private Slack channels. Even the serious scientists could not entirely suppress a superstitious dread, as though the universe were replaying an old experiment, waiting to see if humanity had learned. Across government, the debate reignited: transparency versus containment. The NASA administrator favored an early public disclosure to prevent hysteria. DARPA's counterproposal, marked for internal discussion only, advised a managed rollout with emphasis on infrastructural resilience. The difference between the two approaches was the difference between science and statecraft. Eventually, the National Security Council took control. On January 22, the White House held a confidential briefing titled Cross-Domain Recurrence Event, Status Report. Present were representatives from NASA, NOAA, the Department of Defense, CISA, and AWS. Maria Thompson, now a consultant for digital risk, attended by SecureLink. Her report was blunt: network instability patterns mirror 2025 but originate in a different control domain. Correlation with astrophysical data statistically unlikely. Nonetheless, public perception will assume repetition. Recommend proactive disclosure or we lose control of narrative again. A general at the table interrupted: control of narrative is exactly what we can't afford to lose. The transcript ended there, but those words circulated for weeks. By the end of January, the pattern continued, unbroken. Spectral data from South Africa's Meerkat array confirmed low-frequency modulation. A research group at the University of Chicago attempted to fit the data to natural sources: pulsars, magnetospheric oscillations, solar wind harmonics. None matched precisely. A private memo from NASA's Jet Propulsion Laboratory summarized the growing unease: we are in statistical purgatory, not anomalous enough to claim discovery, not random enough to dismiss. Then came the leak. On February 3, an anonymous whistleblower posted a compressed archive labeled SWNC 2027 to a decentralized storage network. Inside were excerpts of raw telemetry, network metrics, and internal communications from the Spectral Integrity Program. The data was real. The commentary was damning. It revealed that at least 2 analysts within DARPA had proposed testing reactive transmission, sending a precisely timed radio pulse matching the oscillation's phase, to see if the pattern changed. It was an experiment that every SETI researcher dreams of and every security agency fears. The public discovered it instantly. Within hours, their replying to the noise trended worldwide. Official denials poured out, but the damage was irreversible. The notion that the United States might be talking back to an unknown cosmic rhythm ignited everything the first crisis had left dormant: paranoia, awe, unity, and despair. On February 4, tens of thousands of people tuned to online listening parties, broadcasting live streams of static layered with synthesized hums matching the pattern. It became a ritual, an acoustic vigil for a world that still didn't know what it was hearing. Inside the Spectral Integrity Program, chaos reigned. The leak forced immediate lockdowns. DARPA denied authorizing any transmission. NASA claimed the experiment was theoretical only. Yet, one anomaly remained. At 2:11 Universal Time Coordinated on February 5, the oscillation stopped. Entirely. For the first time in a month, the pattern went silent. The moment was surreal. Data analysts stared at flatlined graphs, half relieved, half terrified. The absence felt louder than the noise. "Maybe it was us," whispered an intern at the Canberra Deep Space Station. "Maybe it just waited for us to answer." Within hours, the conspiracy world exploded. "They silenced it," claimed one post. "We made contact," said another. A viral clip looped a famous quote from Green's old lecture, "The cosmos whispers in unexpected frequencies," and captioned it, "And then it stopped." Government agencies scrambled. A joint task force under the Space Cyber Council convened an emergency meeting. The minutes, leaked later, showed uncertainty bordering on panic. One line read, "Systemic artifact decay or external cessation, cannot determine." The lack of closure was unbearable. Maria Thompson, again reluctantly drawn into analysis, wrote a private note to her colleague: "The pattern stopped at 2:11 Universal Time Coordinated. That's exactly 3:11 in Virginia, the same minute as the 2025 event. Coincidence or recursion?" The reply simply said, "Does it matter?" Over the next weeks, the silence persisted. The Spectral Integrity Program released its official statement on February 12. Observed modulation ceased. Investigations ongoing. No external source identified. It was scientifically true and psychologically meaningless. The world, addicted to noise, could not process quiet. As March unfolded, public attention fractured. Some claimed victory, proof that the signal had been artificial and had acknowledged human reply. Others insisted it was an engineered psyop designed to justify more government surveillance. Universities held emergency colloquia. Podcasts declared a new Copernican moment. Meanwhile, in offices and observatories, the professionals quietly went back to work. Reyes, now at MIT, collaborated with Maria Thompson on a private paper titled "Coupled Systems Under Indeterminate Correlation." The paper argued that in hyperconnected environments, unrelated systems will statistically exhibit apparent synchronization events due to shared timing infrastructure and human observation bias. It was an elegant theory. It also explained nothing. Their own appendix admitted that the 2:11 recurrence defied expected randomness. Sometimes, Reyes wrote in a margin, "Coincidence behaves like memory." By summer, the world had moved on again. The stock market recovered. The media found new crises. Yet deep inside a data center in Maryland, automated monitoring scripts continued scanning for recurrences, silent sentinels built after 2025 and never decommissioned. On July 9, 2027, one of them triggered. Not at 3:11, not at 2:11, but at 11:03 Universal Time Coordinated, the mirror of the earlier times. A single log line appeared in the Spectral Integrity Database. Event, July 9, 2027 T 11 hours and 3 minutes C, cross-domain latency sync detected. There was no corresponding astrophysical data this time, no cosmic echo, just a flicker in packet timing, a digital phantom. No one noticed. The system auto-archived the record. But buried in the metadata was an annotation automatically copied from an older template, awaiting next incident. Years later, historians would argue whether the two vanishings and the next noise were real, whether they marked a physical phenomenon, a psychological contagion, or merely the statistical poetry of a civilization drowning in data. But those who lived through it remembered something more intimate, the shared tension of staring at graphs, at stars, at screens, and realizing that for all our instruments, we still measure ourselves through our failures. Maria Thompson retired in 2028, teaching a final seminar called Systems of Silence. Her last lecture ended with a slide showing two overlapping waveforms, one from the 2025 outage, one from the 2027 oscillation. "They're not identical," she said softly, "but they rhyme." The students watched the twin curves fade into a flat line. "That," she added, "is what truth looks like when it forgets which side of the signal it's on." In that moment, the room was completely quiet, as if the universe itself was listening.